Welcome to PRISCI-ANTO Educational Academy. In this session, I am going to explain you the one-dimensional heat equation if the rod is given and the temperatures are kept at some degrees, as well as the degrees will be increased and decreased type problem we are going to study. Let us see the example. The ends A and B of a rod 30 centimeter long have their temperatures kept at 20 degrees C and 80 degree Celsius respectively. A kept at 20 degrees C, B kept at 80 degrees C respectively until steady state conditions prevail. The temperature of the end B is then suddenly reduced to 60 degrees C and that of the end A is increased to 40 degrees C. Find the temperature distribution in a rod after time t. So this is the question. Here the word steady state conditions prevail. That means dou u by dou t is equal to 0. From the one-dimensional heat equation, dou u by dou t is equal to alpha square dou square u by dou x square. That is a one-dimensional heat equation. In this heat equation, steady state conditions prevail means dou u by dou t is equal to 0. So 0 is equal to alpha square dou square u by dou x square. So dou square u by dou x square is equal to 0. If you are integrating, you will get u is equal to ax plus b. So the steady state conditions prevail. The steady state distribution is u is equal to ax plus b. Okay. The answer is steady state 1, steady state 2. Why I have separated two things. The rod is same. I have drawn here end A, end B. 30 centimeter long, starting x equal to 0 to x equal to 30 centimeter long, the rod. The same rod in steady state 2 also I have drawn, x equal to 0 to x equal to 30. At the end A kept at 20 degree. So x equal to 0, u is equal to 20 at A. At B, x equal to 30, u is equal to 80 degrees C respectively. So I have taken u is equal to 80. In steady state 2, the rod length is same, x equal to 0, x equal to 30. But in the question, the temperature of the end B is then suddenly reduced to 60 degrees C. So u in the steady state 1 is 80 degree. It is suddenly reduced to u is 60 degree. That reduced heat we have to, reduced temperature we have to show. That's why I have drawn steady state 1, steady state 2. So u is equal to 60 degree. At the end A, u is 20 degree. In steady state 1, it is increased to 40 degrees C in steady state 2. So u is equal to 40 degree. Now let us see how to find the steady state distribution. So in steady state 1, the steady state distribution is u is equal to ax plus b. When x equal to 0, at the end A, x equal to 0, what is the u? 20. So 20 is equal to ax. X is 0. So 20 is equal to b. So b is equal to 20. When x equal to 0, b is equal to 20. At the end B, in steady state 1, x equal to 30. So in the formula, you have to substitute u is equal to ax plus b. U is equal to 80 is equal to ax. X is 30, 30a plus 20. So 30a is equal to 80 minus 20, 60. So 30a is equal to 60. So a is equal to 2. Therefore, u is equal to ax plus b. A is 2x plus b is 20. In steady state 2, x equal to 0, x equal to 30, the length of the rod. At the end A, u is increased to 40 degree. So I have noted here u is equal to 40 degree. B is 80 degree in steady state 1, reduced to 60 degree in steady state 2. So I have noted u is equal to 60 degree. Therefore, the steady state distribution is u is equal to ax plus b. When x equal to 0, b is equal to 40. When x equal to 30, u is equal to 60 is equal to 30a plus 40. 30a is equal to 20. So 30a is equal to 20 means a is equal to 20 divided by 30, 2 by 3. So u s is equal to 2 by 3x plus 40. 2 by 3x plus 40. Okay. So we have taken us is equal to strength. Next, the boundary and initial conditions are u of 0 comma t. From steady state 1 you have to take u of 0, x is 0, okay, comma t, which is equal to 20 at the end a. At the end b, x equal to 30. So u of 30 comma t is equal to 80. Okay. So u of 0 comma t is equal to 40. For all t is greater or equal to 0, from the steady state 1 we are writing u of 30 comma t, right? So here steady state 1, steady state 2. In steady state 1 you have to select the u is equal to 2x plus 20. U is equal to 2x plus 20 is u of 0 comma 30, which is equal to 2x plus 20, or u of 0 comma t. From the steady state 2 you have to select the two conditions. First condition is u of 0 comma t is equal to 40. U of 0 comma t is equal to 40 from steady state 2. Next, u of 30 comma t is equal to 60. From steady state 2 only you have to select two conditions. Third condition you have to select from steady state 1. So u of x comma 0 is equal to 2x plus 20. The limit is the rod length 0 to 30. So these are the three boundary and initial conditions. The suitable solution is u of x comma t is equal to c1 cos px plus c2 sin px into e power minus p square a square t plus, from the steady state 2 you have written us. So you have to write that us here. So the suitable solution is us plus c1 cos px plus c2 sin px e power minus p square a square t. Us is u of x comma t is equal to 2 by 3 into x plus 40 plus c1 cos px plus c2 sin px into e power minus p square a square t. Take this equation number 1. Now use condition number 1 in equation number 1. Condition number 1 is u of 0 comma t is equal to 40. For x you have to apply 0. So 2 by 3 into 0, 0. So 40 plus c1 cos 0 plus c2 sin 0. Sin 0 is 0, cos 0 is 1. So 40 plus, right, c1 into e power minus p square a square t, which is equal to 40. So c1 e power minus p square a square t, which is equal to 40 minus 40. So c1 is equal to 0. E power minus p square a square t is not is equal to 0. Substitute c1 equal to 0 in equation number 1. Instead of c1 you have to apply 0. So u of x comma t is equal to 2 by 3x plus 40. c1 will be 0 plus c2 sin px into e power minus p square a square t take this equation number 2. Use condition number 2 in equation number 2. What is condition number 2? For x, you have to write 30, comma t. U of 30, comma t is equal to 60. So u of 30, comma t in equation number 2, 30, comma t. So 2 by 3 for x 30 plus 40 plus C2 sin px. X is 30p e power minus p square a square t, which is equal to 60. So 2 by 3 into 30 will be 20 plus 40 plus C2 sin 30p e power minus p square a square t is equal to 60 degree. So C2 sin 30p e power minus p square a square t is equal to 60 minus 60, 0. So C2 is not is equal to 0. We cannot take C2 is equal to 0. So sin 30p is equal to 0. So sin 30p, which is equal to sin n pi. 30p is equal to n pi. P is equal to n pi divided by 30. So substitute P is equal to n pi divided by 30 in equation number 2. So u of x comma t is equal to 2 by 3x plus 40 for P sin n by x n pi divided by 30 for P. So plus C2 sin n pi x divided by 30 e power minus p square a square t. So p square is n square pi square a square t divided by 900. So the most general solution is u of x comma t is equal to 2 by 3 x plus 40 plus summation n equal to 1 to infinity. In general, you can write as bn sin n pi x by 30 e power minus n square pi square a square t divided by 900. Take this equation number 3. Now use condition number 3 in equation number 3. What is condition number 3? U of x comma 0. So for t, you have to apply 0, which is equal to 2 by 3x plus 40 plus summation n equal to 1 to infinity bn sin n by x by 30 into e power 0, because the t is equal to 0. Condition number 3, it is equal to 2x plus 20 summation n equal to 1 to infinity bn sin n by x by 30, which is equal to 2x plus 20 minus 2 by 3x minus 40. So if you simplify it, you will get summation n equal to 1 to infinity bn sin n by x by 30, which is equal to 4 by 3x minus 20. This is half range sine series in the interval 0, 30. So bn is equal to 2 divided by L integral over 0 to L f of x sin n by x by L into dx. This is the formula, general formula. But instead of L, here is 30. So bn is equal to 2 divided by 30 integral over the limit 0 to 30 4 by 3 x minus 20 sin n by x by 30 into dx. So integral uv dx, the Bernoulli's formula, we have to use uv1 minus u dash v2 plus u double dash v3 minus u triple dash v4 plus etc. So u is equal to 4 by 3x minus 20. V is equal to sin n by x divided by 30. U dash 4 by 3. U double dash 0. V1 minus 30 divided by n pi cos n pi x divided by 30. V2 minus 900 divided by n square pi square sin n by x by 30. So if you apply these results in the Bernoulli's formula, you will get Bn is equal to 2 divided by 30. uv1 minus 30 divided by n pi 4 by 3x minus 20 cos n pi x by 30 minus u dash v2 4 by 3 into minus 900 divided by n square pi square sin n by x by 30. The limit is 0 to 30. For x, you have to apply 30 minus for x, you have to apply the lower limit 0. So Bn value, if you apply the upper limit as well as lower limit, some term will be 0, sin n pi will be 0, right? Cos n pi will be minus 1 power n. Cos n pi is minus 1 power n. Sin 0, 0. sin n pi 0, cos 0 1. So if you apply the limit, you will get Vn is equal to 2 divided by 30 into minus 600 divided by n pi cos n pi minus 600 divided by n pi. So Bn is equal to minus 40 divided by n pi 1 plus minus 1 power n. If n is even, minus 80 divided by n pi. If n is odd, Bn value is 0. So Bn value substitute in equation number 3. U of x comma t is equal to 2 by 3x plus 40 plus summation even number to infinity minus 80 divided by n pi sin n pi x by 30 e power minus n square pi square a square t divided by 900. So this is the final answer. Thank you.